Hi everyone. All right, so we're going to talk about what the quadratic formula is. So solving quadratic equations using your quadratic formula. So we're going to talk about what this is. And this is actually on that formula sheet, your reference sheet. But I have found if you just memorize it, it's a lot easier so you're not flipping back and forth. So quadratic formula, it also goes along with this word, this vocabulary word called the discriminant. So if you know your quadratic formula, you'll be able to do the discriminant. So quadratic formula, we're trying to find roots. So we're going to set it x equals, and then we have our opposite b plus or minus the square root of b squared minus 4 times ac. All of that, every piece of it is over 2a. And remember, this is when we have our trinomials as ax squared plus bx plus c, because we use our a, b, and c within this equation, within that formula. And that should give us our roots for the quadratic formula if you cannot factor. Okay, so the only time you would really use this is if they tell you to, or if you cannot factor. Okay, because it can be a long process. So that's kind of like the last resort. So the discriminant determines how many roots we have. Okay, so how many roots are you going to have? So how many solutions? So to find that is just b squared minus 4ac. So to help us, I have this lovely little chart right here. So when this is greater than 0, you're going to have 2 real roots. Okay, that's what this first one says right there. 2 real roots. When your discriminant is greater than 0, you're going to have 2 real roots. When it is equal to 0, okay, when this is equal to 0, you're going to have 1 real root. And then when it is less than 0, you're going to have 2, and we're not even going to worry about these complex roots. You're going to have no real roots. So complex roots are something you're going to talk about in Algebra 2 and in pre-calc with me. So what you need to know at this point is that you have no real roots if it's less than 0. Okay, so we're going to practice this down here. So make sure you have that information. Pause when you need to. And so we're going to go down. We're going to look at number 1. We're going to use the discriminant to just find the number and the type of solutions. So you need to make sure that this is equal to 0, so you have the correct a, b, and c to use in your discriminant. So move that 6 over. So now this is minus 4 equal to 0. And I always like to label my a, b, and c off to the side. I don't like pulling from the equation. I find it's easier, especially with quadratic formula, to just have it listed off to the side right there because it's a lot of information. So 7 squared minus 4 times a, which is 2, times negative 4, which is c. So 49 plus 32, which gives me 81. It is a positive number, so this is greater than 0, which means I have 2 real roots. Okay, 2 real roots. So the number is stated in the type. All right, so that's exactly what you would do for these kind of questions. So for 3, same thing. We're going to move that 5 over. We're going to add it. So 5b squared plus 6b plus 9 equals 0. And we're not trying to find our roots, we're trying to identify how many we're going to have. So 5, 6, and then we have a 9. So b squared minus 4ac, that's our discriminant. So 6 is b, a is 5, and c is 9. So I have 36 minus 180, which gives me a negative 144. So if I look at what I wrote above in my notes, if it's greater than 0, it's 2 real roots. If it's equal to 0, it's 1. And then if it's less than 0, then I have no real roots. That's what we have in our chart over here as well. So it's less than 0, which means I have no real roots. So that means I would have 2 complex roots, which you don't need to write. You can just write no real roots, and that's the answer. Okay? So we're going to go down to this next section. Solve each equation with the quadratic formula. So this is where memorizing it helps, so you don't have to flip back and forth. I'll go ahead and write it up here again. So opposite b plus or minus square root b squared minus 4ac, all of that is over 2a. Again, the only time you would really use this is if they tell you to, which they do here, or if you can't factor. So for number 5, it's already equal to 0, which is big. It has to be equal to 0, so that's good. So I'm going to label my a, b, and c. So a is 2, b is -5, and c is -18. This just helps make sure that your signs are right, so when you go to plug them into your formula, that you're not messing up. You're not messing up, a subtraction and making it positive, so you're not getting different answers. So opposite b, so opposite whatever b is, we're going to put in parentheses, and that's -5, plus or minus. Remember when we substitute, we make sure that we have parentheses so we don't accidentally mess up signs. So then we have 4 times a times c. Okay, make sure that's all in your square root. Make sure your square root covers all of that, so you're not missing something. And then the bottom is 2a. So then opposite b, so opposite of a negative is positive, so that's a +5. So then we have our square root. We're going to take it in pieces. So 25, that's -5 squared. And then we have -4 times 2 times -18. So do it in pieces or pull out your calculator. I'm going to pull out my calculator because I know that's what a lot of you would do. So we've got -4 times 2 times -18. So we have a positive 144. I probably didn't need to make my root that big, so I'm just going to change it. Okay, and then in the bottom, 2 times a, which is 4. I'm just going to keep scooting it over here because you're going to need some room for this. Okay, so 25 plus 144 is 169. Okay, and if we need to check that, we're going to. So 25. And then this was one of the perfect squares that I had you memorize. But in case you forgot, 169 is a perfect square and you get 13. So 5 plus or minus 13 over 4. Now you would not leave this like this. Because you have a number right here and not just a radical, you have an actual simplified number, that 13. You're going to split, you're going to do a plus 13 over 4, and then you're going to do the minus. Okay, you can give me real numbers here because you have a real number simplified from that radical. So x can be, see, that's 18 over 4, which simplifies to 9 over 2. So 18 over 4 simplifies to 9 over 2. And then 5 minus 13, that's -8 over 4, so you could get a -2 here. So your two answers, your two real roots, are going to be 9 over 2 and -2. All right, so that's what it looks like. So we're going to do another one. So we're going to do number 7. Okay, number 7, we need to make sure that all of our terms are on one side. So I'm going to move that 8n over. So 8n squared minus 8n minus 1. I'm going to make sure that my trinomial is in that standard order that we always put it in, so I can make sure that my a, b, and c are right. So a, b, and c, I'm going to list them out. So now I'm going to put it in my quadratic formula. Again, pause if you need to. Just trying to get the most information in the video as we can. Opposite b, so opposite of -8, plus or minus the square root, we got b squared minus 4 times a times c and make sure it's all under that root. So then 2 times a in the bottom. So now we can start simplifying. So opposite of -8 is a positive. And then inside our root, -8 squared is positive 64. -4 times 8 is -32. Times -1 is a positive 32. And then 2 times 8 is 16. Okay, so then 64 plus 32, we should have the square root of 96. Okay, so let's check it just to make sure, because we should always check our math, even those of us who are really good. So it's 96, so we're all right. So 96 is not a perfect square, but I bet that there is one within it. So let's check it. So 96 divided by 4. So we have 4 and 24. Let's see, 96 divided by 16. So 96, perfect square of 16. When they divide, we get 6. So those are the factors I'm going to use. So if you remember, we can split it up, and then we can get the 16 as is a perfect square, so that would be 4 root 6. Okay, so now you wouldn't leave your answer like this either. And I'm going to show you a shortcut of what you need to do. So you wouldn't leave it like this because 8, 4, and 16 all have a 4 in common. Okay, and because this is a fraction, we can reduce, remember reducing? We can reduce it to make it more simple. Now, you're not going to do anything with the root. You can essentially treat this like 8 plus or minus 4x over 16. Okay, just because there's a number in there doesn't mean you touch it. So if it looked like this one, 8 plus or minus 4x over 16, you would only change these numbers that are highlighted. You wouldn't change anything with the x. So we're going to do the same thing down here. So they have a 4 in common, so we're going to divide out of 4. So 8 divided by 4 is 2, plus or minus 4 divided by 4 is 1, so we can just write the root 6 because that doesn't change. And then 16 divided by 4 is 4. Now this is simplified, and we have two answers because of this plus or minus right here. So there are two real answers right there. All right, so you need to make sure that you're reducing and that you treat this radical like a variable and you don't touch it. Okay, only outside numbers, these yellow outside numbers, get reduced. All right, and so that is number 7. I want to show you one last thing because we didn't talk about graphs. So I want to take a look at number 1. Your x-axis is right here, your y-axis is right here. It's kind of hard to see on some of these, so just try your best to find it. So it says find the sign of the discriminant and the number and the nature of the roots. So you can tell by looking at the graph what the discriminant is going to look like. You don't need the A, B, and C to do that. So if I'm looking at my graph, it doesn't cross your x-axis. Okay, that's your x-axis. It does not cross it. And when we look at our graphs before and it didn't cross, we would say it had no real roots because it never crosses. So that would be answer for part B. But for part A with the discriminant, if it has no real roots, that means our discriminant is less than 0. And that's all you would do. So like for number 3, our x-axis is right here and our y-axis is right here. If you look at the picture, we've got a dot here and a dot here. It crosses your x-axis twice, so we have two real roots, which means that our discriminant is greater than 0. Okay, so you're going to use that information from the discriminant, and that's it. That's all you would do for the pictures of the graphs. And then remember you're simplifying for the quadratic formula and using your formula for the discriminant. All right, so I hope this helps. Have a great day.